Today, our shapes that we're going to look at are trapezoids and kites. So we're first going to look at the vocabulary for a trapezoid. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. It has bases, which are the parallel sides, legs, which are the non-parallel sides, and base angles, which are the two angles that share a base. And so down here we have a picture of an isosceles trapezoid. So an isosceles trapezoid is a trapezoid with legs that are congruent. So again, you're given the bases, and those are parallel. Then you have legs, and the legs are congruent for an isosceles trapezoid. And then you have base angles. So base angles are all the angles that are formed inside. So each of these has properties that go along with them. So if you have an isosceles trapezoid, then each pair of base angles is congruent. So base angles share a base. So AB, so angle A is congruent to angle B, those share a base. And then C and D, so angle C is congruent to angle D, because they share that base CD. If you have an isosceles trapezoid, then the diagonals are congruent. So again, if you look at the diagonals here, we're given the isosceles trapezoid, and we know this because the legs are congruent. And so then you can say that AD is congruent to BC. Now, if a quadrilateral is a trapezoid, then the midsegment is parallel to the bases, and the length of the midsegment is half the sum of the length of the bases, which sounds like a lot, but it's really not as complicated as it sounds. So what it's saying is that AB is parallel to EF, and it's parallel to CD, so they're all parallel. And then it's also saying that if I added AB and CD and take half of it, that would be my measurement for EF. So say AB was 10 and AB was 6. I would add them together, that'd be 16, cut it in half, and then EF would be 8. And then lastly, we have a kite. So a kite is a quadrilateral with two pairs of consecutive sides congruent and no opposite sides congruent. So if we look, these consecutive sides here are next to each other for the kite, and then as well as these two consecutive sides. And the theorem that we know about kites is that their diagonals are perpendicular. So the diagonals would cross each other and they would form those right angles. So if we look at some example problems here for number 1, we're going to figure out that all the numbered angles. So we're going to start with our nice and easy one. So this is 60. Angle 3 also has to be 60 because they are the base angles. So we know that the base angles in a trapezoid are congruent. Now we also have to think that angle 1 and angle 2, to figure those out, we know that those angles are going to be supplementary. So angle 1 plus 60 equals 180. And so from there, I can figure out how much angle 1 is, which is going to tell me how much angle 2 is. So I'm going to subtract 60 from both sides. So I get angle 1 equals 120 degrees. And so that is also going to be the measurement for angle 2, because those are the base angles that are congruent. Now for number 2, we have a kite. And so with the kite, I know the diagonals form right angles because they're perpendicular. So angle 1 is going to equal 90 degrees. Now to figure out angle 3, I have a triangle. So a triangle equals 180. So I'm going to do 40 plus 90 plus x for angle 3 equals 180. Then I'm going to combine like terms. So I get 130 plus x equals 180. Subtract 130 from each side. So I get x equals 50. And that's also the measurement for angle 3. For next one here, I have the isosceles. This should be number 3. So for number 3, I'm given the isosceles trapezoid. I have to solve for x. So I'm given that AD equals 20x minus 7 and CB equals 5x plus 23. And what we know about the diagonals is that the diagonals are congruent. So I have 20x minus 7 equals, because congruence is the same as equals, 5x plus 23. And then I'm going to go ahead and solve for x. So I'm going to subtract 5x from both sides. So I get 15x minus 7 equals 23. Add 7 to both sides. 15x equals 30. So x is going to equal 2. And then our last problem should be problem 4. And so this is where that weird equation comes in. So this is saying that half, so EF, which is my mid-segment, equals half, and then in parentheses I gotta add my two bases, so AB plus CD. And then I'm going to plug in my numbers from there. So EF is 5x, keep the half out front, plug in for AB 2x plus 4, and then CD is plus 12. So simplifying, I get 5x equals 1/2 times 2x plus 16. So what I'm going to have to do is I have to distribute the 1/2 through. So I'm going to multiply everything by 1/2 or divide everything by 2. So 2x divided by 2 equals x, and then 16 divided by 2 equals 8. So then I'm going to subtract x from both sides, so I get 4x equals 8, and divide by 4. So that gives me x equals 2 as my final answer.